morning. I am Venkata Rao, Professor of Mechanical Engineering, Department of Mechanical Engineering, IARE, Hyderabad. Now, I will discuss about the topic multi-stage graph using forward approach. Topics to be covered are introduction, dynamic programming, examples. Multi-stage graph. The main objective of multi-stage graph is to find out the shortest distance from the source to sink. The starting vertex is called as the source and the last vertex is called as the sink. It is a directed graph in which the vertices are divided into number of stages. Edges are connected to vertices from one stage to another stage. There are many paths from source to sink. The cost is calculated from the source to sink by using two methods. One is the forward approach and another one is the backward approach. Multi-stage graph problems are solved by brute force approach, Dijkstra approach, greedy method, dynamic programming and dynamic programming method. The best method is dynamic programming because Dijkstra and the greedy methods will take more time compared to the dynamic programming method. Then dynamic programming. It depends on principle of optimality. It finds out all possible solutions and take the best solution. It takes more time to compare with other methods. For solving complex problems, it breaks down the problem into sub-problems and the solution of each sub-problem is found. Then these solutions of the sub-problems are stored and reused for finding out the solution of the complex problem. The dynamic programming is used to solve linear programming, traveling salesman problem, knapsack problem, shortest path problems, longest common subsequence and many other problems. Now consider this problem example. So here source is 1 and sink is 12. So 1 to 2, 1 to 3, 1 to 4, 1 to 5. So these are the paths from the source that is corresponding to stage 1 to stage 2. And then here the total problem is divided into number of stages. One corresponding to source S and stage 1, stage 2, 2, 3, 4, 5, stage 3, 6, 7, 8, stage 4, 9, 10, 11 and last vertex is 12, that is corresponding to the sink T. So that means here the vertices are divided into 5 stages. The 12 vertices are divided into 5 stages. In the first stage, 1 vertex is there. In the second stage, 4 vertices are there. In the third stage, 3 vertices are there. And fourth stage, 3 vertices. And fifth stage, only 1 vertex is there. Now we have to start with the sink T because it is easy to find out the solution. Suppose if you start from 1, it takes more time to calculate the cost. So that's why we are starting with the sink, that is the stage 5. So first find out the cost of the node 12. So this is, we are considering from the starting node 12. In that case, the cost required is equal to 0. So that is represented as cost corresponding to the fifth stage of vertex 12 is equal to 0. So we can explain this problem by using the tabular form. In that vertex 1 to 12 is there. The second one is the cost and third one is the destination. Then from 12 to 9, that means 12 to 9, what is the cost? So 9 to 12, it is given as 4. That means the cost of the vertex 9 corresponding to the stage 4 is equal to 4. Similarly, the cost of the vertex 10 corresponding to the fourth stage is 2, because 10 to 12 is 2 and 11 to 12 is 5. That means the cost of vertex 11 is 5 in the fourth stage. So that is corresponding to the fourth stage. Now we can consider the third stage. So from third stage we have to calculate the cost. So the cost of the vertex 6, the cost of the vertex 6 in the third stage is equal to minimum of cost of an edge. Cost of an edge 6 to vertex 9 plus cost of vertex 9 in the fourth stage, comma, cost of an edge, because you can see in this from the stage 3 vertex 6 is having two parts. One is 6 to 9, another one is 6 to 10. So that we have to find out the cost in both the parts and we have to select the minimum one. So that means we have to first find out the cost of the vertex 6 in the third stage. So cost of vertex 6 corresponding to the third stage is equal to minimum of cost of an edge 6 to 9 plus cost of vertex 9 in the fourth stage, comma, cost of an edge 6 to 10 plus cost of vertex 10 in the fourth stage we have to find out. So first, cost of an edge 6 to 9. Cost of an edge 6 to 9 is equal to, so cost of an edge 6 to 9, that is equal to 6. So 6 to 9 is 6. Then the cost of the vertex 9. Cost of the vertex 9 is equal to 4. We can see in the table also. So now you can write 6 plus 4. 6 is corresponding to the cost of an edge 6 to 9 plus cost of vertex 9 in the fourth stage is 4. So that is corresponding to the one path. Corresponding to the another path, we have to find out the cost of an edge 6 to 10 plus cost of vertex 10 in fourth stage. So cost of an edge 6 to 10, how much? The cost of, now cost of an edge from 6 to 10, that is equal to 5, and cost of a vertex to 10 is 2. So 5 plus 2, that is 7. So in this we have to select the select the minimum one. First one is 6 plus 4 is 10. The second one is 5 plus 2, 7. So that cost of an edge, cost of a vertex 6 is equal to 7. That is corresponding to the vertex 10. So we are marked in the table. So vertex 6 cost is 7 and the destination is 10. Coming to the 7, vertex 7 corresponding to stage 3. So from vertex 7, how many paths are there? 2 paths are there. One is from 7 to 9, another one is 7 to 10. Again, we have to find out the shortest path. For the finding out the cost of vertex 7, we have to write cost of 3 to 7. That means 3 corresponding to the stage, 7 corresponding to the vertex. 3 to 7 is equal to cost of an edge 7 to 9 plus cost of vertex 9. So this is 7 to 9 is 4 and the cost of vertex 9 is 4. So that you can write here. So here cost of an edge 7 to 9 is 4 plus cost of vertex 9 is 4. So 4 plus 4 is 8 corresponding to the first path. Corresponding to the second path, cost of an edge 7 to 10 plus cost of vertex 10. That is equal to, now you see in the diagram. So 7 to 10 is 3 and cost of vertex 10 is 2. 3 plus 2 is 3 plus 2 is 5. So we have to select the minimum values. One is 8, another one is 5. So this 5 is corresponding to the second one. That is vertex 7. Vertex 7, the cost is 5 corresponding to the destination 10. Then coming to the vertex 8 in the third stage. Vertex 8 in the third stage. So in the third, from vertex 8, again two paths are there. One is from 8 to 10, another is from 8 to 11. So again we have to find out cost of vertex 8 in the third stage. So cost of 3, 8 is equal to cost of an edge 8 to 10 plus cost of a vertex 10, cost of an edge 8 to 11 plus cost of an vertex 11 in the fourth stage. In the two values we have to select the minimum. So in the first case 8 to 10 is 5 and cost of vertex 10 in stage 4 is 2. That means 5 plus 2, that is corresponding to the path 8 to 10. Path 8 to 10 is equal to 5 plus 2, that is 7. Next we have to find out the cost of an edge 8 to 11 plus cost of vertex 11. So that is equal to 6 plus 5. 6 plus 5, you can see 8 to 11. 8 to 11 the cost is 6 and cost of vertex 11 is 5. So that you will get that is 11. So in that we have to select the minimum value. So minimum value is 7 corresponding to the vertex 8. The cost is 7 and the destination is 10. Then coming to the stage 2. Next coming to the stage 2. So again we have to find out the cost of stage 2 corresponding to the vertex 2, vertex 3 and vertex 4. Because now you can see the diagram. From stage 2 there are 3 paths. One is from 2 to 6, another is from 2 to 7, another is from 2 to 8. So there are 3 paths are there. By considering these 3 paths, we have to select the shortest path. We have to find out the shortest path. So now we have to find out the cost of vertex 2 in the second stage. Cost of 2, 2 is equal to cost of an edge 2 to 6, cost of an edge 2 to 6 plus cost of vertex 6. That is the one cost. Then other one is cost of an edge from 2 to 7 plus cost of vertex 7. That is the another one. Next one is cost of an edge 2 to 8 plus cost of vertex 8. By considering these 3 values, we have to find out the minimum path. Now you see cost of energy, cost of vertex 2 in stage 2 is equal to minimum of cost of an edge 2, 6 plus cost of vertex 6 in the third stage, cost of an edge 2, 7 plus cost of vertex 7 in the third stage, cost of an edge 2, 8 plus cost of vertex 8 in the stage 3. So in the first case, the cost of an edge from 2 to 6, 2 to 6 is 4, 2 to 6 is 4 and cost of vertex 6 is 7. You can see that in the diagram. Now you see cost of an edge 2, 6 is 4 and cost of 6 is equal to vertex 6 is equal to 7. So that you can consider those 4 plus 7 is equal to 11. Next, cost of an edge 2 to 7. Cost of an edge 2 to 7 is 2 plus cost of vertex 7 is 5. Then cost of an edge 2, 8 is 1 and cost of vertex 8, that is 7. You can see in the diagram. Now you can see in the diagram. So 2 to 7 is the cost of an edge 2, and 2 to 8, the cost of an edge is 1. So by considering this, we have to consider the cost of vertex 7 and cost of vertex 8. Now, so 4 plus 7, 11, 2 plus 5, 7, 1 plus 7, 8. So there are 3 values are there, so that we have to consider the minimum value. That minimum value is corresponding to 2 plus 5 is 7, that is corresponding to the vertex 7. So vertex 7, the cost is vertex 2, the cost is 7, that is corresponding to the destination 7. Then coming to the vertex 3, corresponding to the vertex 3 in the second stage. So now we are considering the another path. Now we are considering the another path. So 3 to 6. Now considering the other vertex 3, from the 3, 2 paths are there. One is 3 to 6, another one is 3 to 7. So 3 to 6, the distance is cost of an edge 3 to 6 is 2, and cost of an edge 3 to 7 is 7. By using these two values, we can find out the cost corresponding to the vertex 3. So cost of vertex 3 in the second stage is equal to minimum of cost of an edge 3 comma 6 plus cost of vertex 6 in the third stage plus comma cost of an edge 3 to 7 plus cost of vertex 7 in the third stage. So in this we have to select the minimum value. The first one is 2. 2 plus 7, that is 2 is the cost of an edge from 3 to 6 is 2, and the cost of vertex 6 is equal to 7. The next one is cost of an edge 3 to 7 is 5. 3 to 7 is 7 plus cost of vertex 7 is 5. So 2 plus 7 is 9, 7 plus 5 is 12. So that we are getting two values. One is 9, another one is 12. In that we have to select the minimum value. Minimum value is 9, that is corresponding to the vertex 3 and destination 6. Then the next path is 4. We have to consider from the vertex 4. From the 4, only one is there, one path is there, so that we can straight away consider that 4 to 8. The cost of an edge 4 to 8, 11 plus cost of the vertex 8. So 11 plus 7, 11 plus 7 is equal to 18. We have to take corresponding to the vertex 4, the cost is 18, that is corresponding to the destination 8. Then coming to the another path, that is, so that is another path is 5 to 7 and 5 to 8. This is corresponding to the vertex 5 in the second stage. Vertex 5 in the second stage. So here again we have to find out the cost corresponding to vertex 5. It is having two paths. One is 5 to 7, another one is the 5 to 8. So this can be calculated like this. Cost of an edge 5 to 7, that is 11 plus cost of vertex 7. Next one is cost of an edge 5 to 8 plus cost of vertex 8 in the third stage. Now corresponding to the cost of an edge 2 to 5 is equal to cost of an edge 5 to 7. 5 to 7 is 11 plus cost of vertex 7 is 5, and another one is cost of an edge 5 to 8 plus cost of vertex 8, that is 7. That means, so 11 plus 5 is 16, 8 plus 7 is 15. In that minimum is 15, that is corresponding to the vertex 8. That is corresponding to the destination 8. So corresponding to the 5, the cost is 15 and the destination is 8. Next, so we have to find out the cost corresponding to the starting vertex. Now you see, from the starting vertex or source, how many paths are there? There are 4 paths are there. one is 1 to 2, another one is 1 to 3, and third one is 1 to 4, and fourth one is 1 to 5. There are 4 paths are there. We have to find out the cost corresponding to all the 4, and then we have to find out the shortest one we have to select. Now, first we will find out the cost corresponding to vertex 1 to 2. We have to find out the vertex 1 to 2, and then 1 to 3, and then 1 to 4, and then 1 to 5. So, and then we can select the minimum one. So, cost of vertex 1 in stage 1 is equal to a minimum of cost of an edge 1 to 2 plus cost of vertex 2 in the second stage, comma, cost of an edge 1 to 3 plus cost of vertex 3 in the stage 2, comma, cost of an edge 1 to 4 plus cost of vertex 4 in the second stage plus, not plus, comma, cost of an edge, this is, comma, we have to consider the minimum values. Okay, cost of an edge 1 to 4 plus cost of vertex 4 in the second stage, comma, this is, comma, cost of an edge 1 to 5 plus cost of vertex 5 in the second stage. So, in that we have to select the minimum. In the first case, what is the cost corresponding to 1 to 2? Now, see the diagram. So, 1 to 2, the cost is 9. The cost is 9 corresponding to 1 to 2. And cost of an edge from 1 to 3 is 7. 1 to 4 is 3. 1 to 5 is 2. We have to consider these costs. Now, you see, the cost corresponding to 1 to 2 is 9. 1 to 3 is 7. 1 to 4 is 3. 1 to 5 is 2. Then we have to consider the cost of the vertex. Cost of vertex 2 is 7. Cost of vertex 3 is 9. Cost of vertex 4 is 18. Cost of vertex 5 is 15. So, now find out the values. 9 plus 7 is 16. 7 plus 9 is 16. 3 plus 18, 21. 2 plus 15 is 17. So, in that minimum is 16. So, this 16 is corresponding to 2 vertices. One is 2, another one is 3. So, that's why in the destination 2/3 is given. That means either we can consider the 2 or we can consider the 3 because the total cost is 16 in the both the cases. Now, actually we calculated the costs. Actually, the dynamic programming technique is now we have to use it. So, actually we have to take the decision from stage to stage. The first one is, now starting vertex is 1. So, now we have to start D of 1. That is first stage, first vertex. Then where to go? We have to go to 2 because the cost is minimum. So, what is that one? 2. So, 1 to 1. So, that is stage 2 we have to go. Then we have to see. So, we have to go from stage 1 vertex 1 to stage 2 vertex 7. Vertex 7 we will see how it is. Now, we have to go from, this is the 2. This is 2. That means this is the second vertex. We are going from first vertex to second vertex. Now, from second vertex to where we have to go? We have to go 7. From second vertex to we have to go to vertex 7. Then from seventh vertex to go where? So, now we have to find out. We have to go in stage 3 from 7. From 7 to where we have to go? 7 to 10, 7 to 10. So in the destination we can see corresponding to 2, 7 is the destination, corresponding to 7, 10 is the destination. Then in the fourth stage where we have to go 10 to, so 10 to 12, 10 to 12. So now what is the path? So the path is 1 to 2, 2 to 7, 7 to 10, 10 to 12. So this is the path. So here highlighted here 1 to 2, 2 to 7, 7 to 10, 10 to 12, and the total cost is 16 because we consider the 2 first. If you consider the 3, again we have to find out the path. Okay now. So destination 1 comma 1, that is the stage 1 corresponding to the stage, another corresponding to the vertex. So D destination of 1 comma 1 is equal to 2. Destination of second stage, second vertex is 7. So we have to go from second to 7th. That is stage 1 to stage 2. That is vertex 2 to vertex 7. Then vertex 7 to vertex 10 and vertex 10 to vertex 12. So like that we can find out the path. If the third vertex is concerned, how to find out the path? If the third vertex is considered, so D of 1 comma 1 is equal to 3. That means we are considering from first vertex to third vertex. Then we are going, this is from second vertex, second stage, third vertex. From third vertex, where we are going third vertex to 6. We are going sixth vertex. From third to 6th, the destination is there in the 6 corresponding to the vertex 3. Then from stage 3, where we are going to 6. From 6 to where we are going 6 to 10. So the destination is 10. So that we can write 10. Then in the fourth stage, we can write 10. So from 10 where we are going, that is 12. So like that we can find out the path. That is also represented with red color indicated. That is 1 to 3, then 3 to 6, then 6 to 10, 10 to 12. So we can find out the cost either by using the vertex 2 or vertex 3 because both are having the same cost. So that in this problem we will get 2 solutions. Example 2. So this is the another problem. Here the first one is the source, this 9th one is the sink. Okay. Now again these 9 vertices are divided into 5 stages. Now so stage 1, stage 2, stage 3, stage 4 and stage 5. Again we have to find out the cost by using the forward approach. Even though we are using the forward approach, but we are first finding out the cost from the sink to source because it is easy, because number of paths are less from the 4th stage to 5th stage. We are considering 9th is the sink. Okay. Then we have to find out the cost. The cost of the vertex 9 with reference to 9 is 0 only. Cost of the vertex 9, that is the end stage, we can say that is equal to 0. So that destination is 9. Then coming to the 4th stage. In the 4th stage, there are 2 vertices are there. One is 7 and another one is the 8. From 7 to 9, what is the cost? The cost is 7. That means the cost of vertex vertex 7 in the 4th stage is 7 and the destination is 9. That means we are going from 7 to 9. 7 to 9, the destination is 9 and the cost is 7. Now from 8 to 9, what is the cost? 8 to 9, the cost is 3 and again the destination is 7. The destination is 9. The cost is cost from 8 to 9 is 3, so that the cost is equal to 3 and destination is again 9. So that is marked. Corresponding to 7, destination is 9 and cost is 7. Corresponding to 8, cost is 3, destination is 9. Corresponding to 9, destination is 9, cost is equal to 0, because we are considering from the end vertex. Now we have to find out the cost corresponding to the vertex 4, vertex 5 and vertex 6 in the stage 3. We have to find out the cost corresponding to vertex 4, vertex 5 and vertex 6. Now we have to find out the cost of vertex 4 in the third stage. Third stage is equal to minimum of cost of an edge 4 to 7 plus cost of vertex 7 in the fourth stage. That is the one path. The another path is cost of an edge 4 to 8 plus cost of vertex 8 in the fourth stage. Now you see the diagram. So cost of from stage vertex 4, there are two paths are there. One is 4 to 7, another one is 4 to 8. 4 to 7 and 4 to 8. Now we have to find out the cost corresponding to the 4 to 7 and 4 to 8, and then we have to select the minimum one. 4 to 7 cost of an edge is 1, 4 to 8 cost of an edge is equal to 4. So by using these two values and also the cost of vertex 7 and cost of vertex 8, we can find out the shortest path. Now you see cost of an edge 4 to 7 is 1 and cost of vertex 7 is equal to 7. So that is the one cost. Another one is cost of an edge 4 to 8 is 4 and cost of vertex 8 is equal to 3. You can also see the table cost of vertex 8 cost is 3. So that 4 plus 3, 1 plus 7 and 4 plus 3. So that 4 plus 3 is 7. That is corresponding to the 8. That is corresponding to the destination 8. So now you see vertex 4, the cost is 7 and destination is 8. Next, coming to the vertex 5. Coming to the vertex 5, that is equal to cost of an edge 5 to 7 plus cost of vertex 7 in the fourth stage, comma, cost of an edge 5 to 8 plus cost of vertex 4 to 8. Again, see the diagram. 5 from 5, there are two paths are there. One is 5 to 7, another one is 5 to 8. 5 to 7, the cost of an edge is equal to 6. 5 to 8, the cost of an edge is equal to 2. Substitute these values here. So, cost of an edge 5 to 7 is equal to 6 and cost of vertex 7 is equal to 7 and cost of an edge 5 to 8 is 2 and cost of vertex 8 is equal to 3. So that we have to take the minimum of 6 plus 7 and 2 plus 3. 6 plus 7 is 13, 2 plus 3 is 5. The minimum is 5. That is corresponding to the vertex, that is the destination 8 or vertex 8. So you can write the same thing corresponding to the 5. The cost is 5 and the destination is 8. Then coming to the vertex 6. Coming to the vertex 6. So from 6 again, there are two paths are there. One is 6 to 7, another one is 6 to 8. You can find out the cost by considering the cost of an edge 6 to 7 and cost of vertex 7. And 6 to 8, cost of an edge 6 to 8 and the cost of the vertex. Now you calculate the values and select the minimum one. Cost of vertex 6 in the third stage is equal to minimum of cost of an edge 6 to 7 plus cost of vertex 7 in the fourth stage, comma, cost of an edge 6 to 8 plus cost of vertex 8 in the fourth stage. So, cost of an edge 6 to 7 is 6 and cost of vertex 7 is equal to 7. 6 plus 7 is 13. Then cost of an edge 6 to 8. 6 to 8 is 2 and cost of vertex 8 is 3. So 6 plus 7 comma 2 plus 3. So 13 comma 5. In that 5 is the minimum. 5 corresponding to the vertex 8. That is their destination is 8 and the cost is 5 corresponding to the vertex 5. Next. After calculating the cost in the third stage, next we have to find out the cost in the second stage. So now you see in the second stage how many paths are there. In this stage 2, there are two paths from vertex 2, that is 2 to 4 and 2 to 6. And in the vertex 3, there are three paths are there, 3 to 4, 3 to 5, 3 to 6. That means first we have to find out the shortest path from 2 to 4 and 2 to 6. After that, we have to find out the shortest path 3 to 4, 3 to 5, 3 to 6. In the three paths, we have to select the minimum one. First, we will calculate the cost corresponding to the vertex 2 in the stage 2. So that means we have to find out the cost of an edge 2 to 4 plus cost of vertex 4. Cost of vertex 4 in the third stage. And then cost of an edge 2 to 6 plus cost of vertex 6. Now, cost of vertex 2 in stage 2 is equal to minimum of cost of an edge 2 to 4 plus cost of vertex 4 in the third stage, comma, cost of an edge 2 to 6 plus cost of vertex 6 in the third stage. So, the cost of an edge 2 to 4 is 3 and cost of vertex 4 is 7 in the table, so that you can write 7. For the cost of an edge 2 to 6 is 3 and cost of vertex 6 is equal to 5. 3 plus 5 is 8. One is 10, another one is 8. So you select the minimum value 8, that is corresponding to the vertex. So vertex 6, that is corresponding to the vertex 6 and the cost is equal to 8. Then 2 to 3. Cost of vertex 3 is equal to minimum of cost of an edge 3 to 4 plus cost of vertex 4, comma, cost of an edge 3 to cost of an edge 3 to 5 plus cost of vertex 5 in the third stage, and that is, so cost of this one and cost of this one, this is also comma, cost of an edge 3 to 6 plus cost of vertex 6 in the third stage. So again we have to find out the values. This is 6 plus 7, comma, 3 plus 5, 8 plus 5. So the values are 13, 8, 13. Minimum is 8. So we have to select the minimum 8, that is corresponding to the second one. So cost of the vertex 3 is equal to 8 and the destination is 5, that is the vertex 5. Then after calculating the cost from the second stage, next we have to find out the cost from the first stage. From the first stage, the cost from the first stage there are two paths are there. One is 1 to 2 and another one is 1 to 3. So in that 2 we have to find out the shortest path. So for that we have to find out cost of vertex 1 in the first stage is equal to cost of an edge 1 to 2 plus cost of vertex 2 in the second stage. In the second stage, comma, cost of an edge 1 to 3 plus cost of vertex 3 in the second stage. So in that we have to select the minimum values. Now you see cost of 1 comma 1, that is cost of vertex 1 is equal to minimum of cost of an edge 1 to 2 plus cost of vertex 2, comma, cost of an edge 1 to 3 plus cost of vertex 3 in the second stage. So the values are cost of an edge 1 to 2 is 5 and cost of vertex 2 is equal to 8. 5 plus 8 is 13 and then cost of an edge 1 to 3 is 2 and cost of vertex 3 is equal to 8. So you can see the values here also, 8 and 8. You can write that values and then 5 plus 8 is 13, 2 plus 8 is 10. So the general formula is cost of stage I stage I, comma, vertex j is equal to minimum of cost of an edge j to L plus cost of I plus 1, comma, L. This is the formula you can use for finding out the values. Then, after finding out the values, we have to take the decision in each stage. So, by using the dynamic programming technique, we have to find out the decision in each stage. Now, so we are starting from the vertex 1. Then, where we are going? So, stage 1 to, we are going vertex 3. From vertex 1 to vertex 3, we are going. Then, so, because here the cost is 10 and the vertex is 3. 1 to 3. We are going from 1 to 3. From 3, where we are going? 3 to, so 3 to 5. 1 to 3, then 3 to 5. So, you can write destination of 2, that is second stage, third vertex is equal to 5. So, 5 is the next vertex. From vertex 5, where we are going? From vertex 5 to 8. So, 5 to 8 we are going, because the destination is 8 corresponding to the 5. So, 5 to 8. Then next, from 8, where we are going? From 8 to 9. So, 8 to 9 we are going. So, 8 to 9. So, we can find out the path. What is the path? 3 to 5, 5 to 8, 8 to 9. So, that is the 1 to 3, 3 to 5, 5 to 8, 8 to 9. So, this is the shortest path. So, by using the dynamic programming technique, we found the shortest path. The solution is, the cost is 10 and the path is 1 to 3, 3 to 5, 5 to 8, 8 to 9. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.